Now ask our next speaker, Dr. Murthy CHAVALI, to turn on his camera while I introduce him. Dr. CHAVALI is Professor of Analytical Chemistry and Nanotechnology, and he serves as a Director of the SVRM College and is Executive Director of Aarsha Nanocomposite Technologies in India. If you flick on his biography details, my word, the number of citations and awards that you have, Murthy, is truly impressive. I am in awe to be in your presence. I'd love to read them all, but I'm not going to because I want to preserve the time so that you can take us through your deck. I'm going to hand straight back over to you.
Thank you. I think you can hear me. Okay.
Yep, we can hear you perfectly.
Okay.
But we can't see your slides.
It's going on.
Okay. Good.
Is it visible?
Not yet, no. If there's a problem, I might ask Rado or one of the other organizers if they could share the slides on your behalf, and then maybe you can just...
That's right. That's right.
Can we do that, please? There we go. Gajana has kindly shared them. So you can just talk, and if you just start saying next slide, please, that's the way to do it.
Yeah. Okay. Anyway, there is some slight change in the fonts and colors because of change in computer. Anyway, I'll go ahead and I'll stipulate myself for 20 to 25 minutes. Thank you for having me here in this wonderful event, Water and Biotechnologies. And as you know from my slides, I'm going to talk about very generally on some of the nano and biotechnologies for water. Next slide, please. And in this particular presentation, I'm going to talk a little bit on industrial challenges, water challenges, what are the technologies, what is the role of technology in purifying this water, and also what are the research options that we have specifically towards nanotechnology and biotechnology, what is the role of nanobiotechnology in water purification, and so on and so forth. If time permits, I'll be talking a little bit about digitalization and summarize everything at the end. Next slide, please. Yeah, this is the most primitive most slide, just to give an impression that the level percentage of the pure water what we have for drinking is just 2.5%, and of which 30% is already in the form of groundwater, rest is in the lakes, and whatever available is very, very little. So there is a need for us to go ahead to preserve, reclaim, reuse, whatever it is, to have the next generations. Next slide, please. Water is at its scarcity levels, and it is not just accessing drinking water, but also about the sanitation and other things like climate change, where we have melting of glaciers, rising sea levels, and longer droughts compared to earlier years. Lack of clean and fresh water. Approximately 1.2 billion people are inadequate of fresh potable water, and at the same time 2.6 billion people, they do not have any hygienous water, and millions are going to die, and at the same time millions are dying because of health related issues and sicknesses. And for example, by 2025, as per the report of United Nations, 1.8 billion will be living with water scarcity, and the demand for irrigation is also going to jump by 15%. This is the report prepared by United States. And 2025 is not going to be very far, just 4 years from now. Next slide, please. And the challenges that we include, not just pollution, but the impacts of climate change, resurgence of water-related diseases, and also our ecosystem destructions. And one of the top 5 trends impacting water industry over the next decade is mounting effects of extreme weather events, protecting agriculture production, as we need a lot of productivity over the generations to come, and also reusing the wastewater to support a circular economy and customer-led revolution. Plus, at the same time, we also need to use smart and intelligent network technologies. For example, if you take by 2050, in the US, it could be rising by 5.7 degree Fahrenheit, which means we are going to have a lot of more frequent and more intense heat waves and even droughts, which is very much possible. As we know, that as the temperatures warm up, you have losses in the form of evaporations and decrease in volume of water in the lakes and so on and so forth. We have reduction in potable water. Next slide, please. And if you compare this with industry challenges, we have 5 challenges where we have, can you go to the next slide, please? We have 5 challenges compared to the industry. One is aging infrastructure and maintenance of the same, managing the cost with the rising electricity prices, and at the same time, growth of urban population, and also environment and sustainability, skills in shortage, and aging workforce. And all these things can be done by simply using IoT-enabled sensors to some extent, and other remote monitoring, and so on and so forth. We have to face these water challenges because of rapid industrialization and rapid globalization. So these are some of the industry-oriented water problems that we are going to face in the coming years. Until we address these 5 challenges, we are going to face severe drought conditions with water, especially related to industrialization. Next slide, please. And it is generally considered as a white goal for the 21st century because we have a lot of depletion and a lot of things are going to happen just because connected with water, and we need to preserve this particular sector in different ways possible. Different technologies can be applied, and at the same time, primitively we can say use of telemetry, remote connections, and the meters to manage software for water volume collection without need to go there, and integration of third-party systems with existing systems. I'm going to talk about a little bit in 1 or 2 slides about the integration of third-party systems, and at the same time, implementation of these things could also create market opportunities within different industries, and finally, we'll be able to use water sustainably. And at the same time, promoting the creation of increasingly powerful network infrastructure will also lead to overcome all these problems for sustainable use of water. Thank you. Next slide, please. And if you talk about water technologies, for especially in terms of purification, there are n number of technologies, n number of startups are going to come up or coming up, and especially in Gulf countries, Europe, and other places, we have a lot of desalination plants. And if you talk about specific technologies where people are trying to use from different fields, engineering, sciences, applied sciences, and nanotechnology, you have nanotechnology for filtration, like ultrafiltration and nanofiltration, depending on the type of mineral content that you need to have for a different purpose, and the membrane chemistry, seawater desalination, smart monitoring. Especially this is being used in developing countries and in the Gulf, especially in the Europe. Spain is leading in one of the smart monitoring systems, and also you need to have intelligent irrigation systems and wastewater processing, reuse, reclamation, and also in petroleum and oil gases industry where you use a lot of water, you need to have mobile recycling units or recycling facilities. Plus, at the same time, you also have biotechnology, which is one of the top themes for this particular event, one-day event in water technology. So I'm going to concentrate a little bit on some of the work that we have done for water purification using nanotechnology and biotechnology, and I'll touch upon 1 or 2 other points during the course of my presentation. And as I said, it is going to be a general talk, not deep technical into the very specific details of nanotechnology and biotechnology. Next slide, please. And if you have some innovations in the sense enhancement of anything that you have in the present day, could lead to innovations either in nanotechnology or biotechnology. And these innovations will advance water sustainability and resilience worldwide. Definitely, it is going to improve our performance in small systems rather than having a huge system set up at one place instead of portable, movable, smaller systems in everywhere where scarcity of water is there, and reducing water impacts on energy production. Nowadays, we have systems and technologies where you produce, where you treat water, and at the same time you produce some of the byproducts in terms of energy or any other purpose of usage. So it is one of the innovative ideas where you have byproducts and 100% treatment. For example, microalgae and macroalgae, where we use treating algae, algal biomass, and at the same time we produce bioethanol or biohydrogen, whatever it is. And also we can grow infrastructure, markets will develop, and at the same time employment chances are there. And it will be the best source, having less economics and at the same time higher innovations to access safe drinking water and sanitation purposes. Application of nanoscale iron, for example, to treat calcitrant and toxic industrial solvents in groundwater, having nanoscale sensors, minute microscopic or very simple nanosensors that have been used, because these sensors are going to come down in the cost, and effectively they are going to monitor and tell you from one place to other remotely, where there is no need for you to go there and measure the volume or the contaminant level. It can be addressed over IoT. So IoT-based nanoscale sensors are one of the real-time solution for in situ detection of chemical constituents and also pathogens. Usage of simple nano filters. I'm going to talk about one of the nano filter that we have developed, which is less than $1 to produce, and nanobiocides and magnetic nanoparticles. And these are specific things where you can remove the pathogens, and at the same time, you can do it by yourself. You don't need any specific intelligence or knowledge for applying these things. And also some of the photocatalysts where they can have, they can be used for pathogen removal or target some of the pathogens, and at the same time self-sterilizing containers for on-site potability of the water, and some of the filters that you may require to agglomerate and make it potable to drink immediately within few seconds. Next slide, please. For example, if you talk about technologies, there are 10 most important ways where you can develop, considering the real need. 1 in 9 people in the world have less access or no access to clean drinking water, and 3 to 4 million die yearly because of waterborne diseases. And this is being added with growing global population and climate change, which is also very much threatening. And for this particular reason, there are many startups coming up with to tackle water problems, and at the same time, biotechnology and nanotechnology is being added. You need to have innovative ideas like powering cars with hydrogen, using less amount of fuels, greenhouse gases. Everything can be decreased, and also you have large resource of saline water where you can desalinate them, and also you can utilize and apply big data and artificial intelligence to these things, and designing some of the existing systems, and use of drones and data, and high-tech filtration unit like simple low-cost nanofilters for bulk scale, so that all these technological ways we can develop, we can enhance, we can grow, and at the same time we can also treat the existing water so that this can be used for next coming generations. Next slide, please. What are the options we have in balancing the demand and also using the available water resources? We have plenty of sources, not just this, but one of the 5 options that I have designed is better water management and conservation, usage of technologies, not just nanotechnology and biotechnology, but any simple technology, cost effective. It can be used by a common man, which is required to balance as per the requirement of demand, and at the same time reuse untreated water, and also reclaim the wastewater in different ways. So these are not just the top 5 options, but some of the options which can be easily be maintained and where you can balance this water demand with the water resources. Next slide, please. As I said, nanotechnology will play a vital role in water purification technologies, because this is one of the area where we are working on for different biomedical sensors, chemical, physical sensors, and integrating them with IoT, artificial intelligence, and wireless sensor networks. And at the same time, nanotechnology holds a future for completely removing effectively, making potable water. And at the same time, there are different types of nanomaterials. Why we use nanomaterials or nanoparticles? Because they have unlimited unique properties that can be tailor-made for our requirement. At the same time, we can also fine-tune these properties using these nanomaterials. For example, if you take carbon nanotube, they have surface area and small volume, and tunable surface chemistry, because you can make them bond with other things, and you can do as your requirement. They have high mechanical strength, they have high chemical stability, they also have absorption properties, antimicrobial activity, so on and so forth. And using this nanotechnology, I'll try to give one of the examples for oil spill and one as a water purifying system. And also, if time permits, I'll go with electrochemical carbon nanotube filters. Next slide, please. Yes, one of the major thing what many people are doing is desalination, and to need to cover the existing population, and because of rapid urbanization and industrialization, more and more cubic meters of water, fresh water is required. Currently, there are around 63 million cubic meters of water is being desalinated over 14,000 plants globally each day, and especially 10% comes from Europe, and of which Spain is the one which is very much leading, and at the same time you have a lot of 700 plants, plus Europe also holds 10% of global desalination system, and there are so many other titanium oxide catalysts, etc., for usage of this thing, and at the same time we are also interested in following and scaling and monitoring of other things using different types of techniques. Next slide, please. And combining this with the desalination system, solar water system, Newt Center in Rice University, Texas, people have integrated solar technology by using light harvesting, nanophotonics, and membrane distillation technology, where they were able to develop 17.5 kilowatts per meter, and at the same time using concentrated sunlight of by 25 times. So this has been increased per square meter by 6 liters. So integrating one technology with other in an effective way could also solve this water purification problem. Next slide, please. Next slide, please. And you have a lot of nanotechnologies and innovations. Why we use nanotechnology? As I said, it has a mobility to fine-tune and tailor-made some of the nanoparticles depending on a number of properties. As you can see, you have water solubility, physical binding, and accumulation, agglomeration, all these things, chemical reactivity and stability, aggregation behavior, everything can be monitored using tailor-made nanoparticles. Next slide, please. And desalination can be done in different ways: thermal, mechanical, electrical, chemical, and so on and so forth properties. But only one problem with this is if it is drinking water, desalination may not serve the purpose because the mineral content is going to be very, very less compared to our drinking water. But still, it can be used for different industrial purposes. And compared to the options that we generate because of desalination, one of the best way by integrating different techniques into desalination, this is going to be one of the best way in reclaiming our water, either wastewater or seawater. Next slide, please. And coming to membrane process, which nanotechnology also very well deserved with nanofiltration, ultrafiltration, microfiltration. This is a typical slide where you can see different types of pathogens and particles that are being present in the raw water, and you can see onto your left-hand side different types of techniques that we use. Based on the technique, we can tailor-made our nanoparticles for that particular purpose, and it can be employed for enhanced membrane processes using either microbiology or biotechnology or nanotechnology. Next slide, please.
Murthy, can I just give you a sort of time flag here and ask if you could look to wrap up in the next 2 or 3 minutes?
That's right.
Thank you.
Yeah. This is one of the graphene-based filter, and where they can have 97% of purified things. That means they can remove 100% of these particular things. And when commercially this has been made, they came to 97%. Next slide, please. But this particular graphene-based desalination unit reduced the cost by 40%. And coming to other thing where graphite, where they used heat-powered membrane distillation. With this, they were able to do so many other things, and at the same time, they can also convert this particular type of unit, not just for desalination, but also for oil spills and pathogen removal. Next slide, please. And other oil spill recovery systems for water purification units. This also can also be used, but not very efficient. But number of cycles can be used for up to 5 times, and this can be applied in high and low level petroleum hydrocarbons. Next slide, please. This is one of the things what we have developed using different polymers as polyurethane dishwashing sponge. The idea of this is, I'm not going to run the video, but still, this converts the entire oil spill taken up by 5-fold by this particular sponge, and the water in which oil is there can be immediately drinkable. That means it is converting itself into a potable thing. Next slide, please. Biotechnology is going to convert the entire water industry, which is going to be the next frontier, and it has so many other alternatives in removal. One of the best thing is capturing phosphorus from wastewater and using it as fertilizer. One of the best example for biotechnology in wastewater treatment. Next slide, please. Next slide, please. And the recent biotechnologies in wastewater is microbial biotechnology, where we are trying to use different types of algae for treating industrial wastewaters, and also saline waters, where algae are largely grown in highly saline waters compared to others. And we are also using some of the green synthesis nanobiotechnology and combining nanotechnology with biotechnology. So new field of nanobiotechnology for wastewater treatment has been aroused. Next slide, please. Some of the biomimicking things like encapsulation, biomemory, bioaugmentation are typically used for wastewater treatment. And these are some of the examples that have been listed out here. Next slide, please. And we also use in our particular area where specifically biotechnology used for in 2 domains. One is increasing productivity under water scarcity, and at the same time improving the efficiency of use of applied irrigation water using biotechnology means. And we have so many sectors in this particular area where we are trying to produce in different areas where we apply biotechnology tools for specifically using less amount of water and increase the productivity. Next slide, please. And coming to the potable water biotechnology, where we have a lot of benefits, reduced costs, and at the same time minimal environmental footprint, and at the same time consumption of available drinking water is minimized and resources can be reused, so that all these things can be done by bioaugmentation or using any biotechnologies for safe drinking of water. Next slide, please. And as I said, we are using nano filters which we have prepared. Go to the next slide, please. In this, we try to develop a filter using a cellulose sandwiched with graphene oxide and a people leaf substrate, where we try to use less than $2 of this particular filter for completely removing the pathogens and contaminants, and they made it possible for drinking. And we also use this for dye removal, where removal of the dye is 86 to 90%. Next slide, please. Next slide, please. These are some of the examples where we use different dyes and membranes. Next slide, please. And some of the microorganisms that have been done by our group, and also we produce biohydrogen and bioethanol during the course of treatment using microorganisms. These are some of the other examples. Next slide.
I'm afraid I'm going to have to jump in. We've got one last
Yes.
with a video. Can I ask you to jump to your last slide, please?
Yes, it's done. Next slide. Next slide, please. I'm not going to talk about anything. And with this, I'll try. I hope it's a general lecture where I've given some information about our research work on nanotechnology and biotechnology. And of course, I did not talk about the 4 pillars of biotechnology, but still, this is useful for making potable water under purified conditions for using biotechnology. Next slide, please. Yeah, these are some of the references. Next slide. Thank you for your attention.
Murthy, I wish I was one of your students. You know, it's like drinking from a fire hose. There's so much information there that
my apologies. I could not do it in a proper way because of some problems with the internet.
That's fine. It's not a problem. I think we got the gist of just how deep your expertise is and how influential this area of chemistry could be to making water treatment and water processes better in the future. So thank you for that.
Thank you very much.
Now,